Okay, so this particular lesson is about two variable inequalities, both lines and absolute values. We've taken both of those lessons and tied them into just one because essentially you're going to be doing the same sort of process. We already know how to graph linear equations and we already know how to graph absolute value equations. So this is just basically shading that we're adding on top of what we're already doing. So to review, and I know that you already know this, but let's just review it anyway. These inequality symbols all mean something different, okay? So this one means less than, and I know some students still get these really confused. I always think about this, it looks like an L, like less, L for less than, okay? So this one is less than or equal to. All right, greater than, and greater than or equal to. All right, so the things that I want you to know or write beside them for later are this one is dashed. This one is also dashed. Now, the ones that do not include the equal sign are dashed, and the reason they're dashed is because just that. They do not include the points on the line. These two that include the equal sign are solid, okay? These guys are solid, and that is because the points on the line are included, right? So that's the difference between the two. For the solid, points on line are included, and these two dashed ones, points on the line not included. So just the lines above or just the lines below, but not the points on the line. Okay, so that's the difference between the two. So a linear inequality, let's define it. It's a two-variable function. That means there's two unknowns. Two-variable function whose graph is a region bounded by a line. Okay, two-variable function whose graph is a region bounded by a line. So let's go ahead and scroll our page up and then we're going to work on this problem. Here's an example of a two-variable linear inequality. I'm going to do two of them. I'm going to scoot this up just a little bit so we can get both of them in there at the same time, okay? So first, graph your boundary line. So basically, what does that mean? That means graph your line. Okay, and remember, we're always thinking mx plus b. So slope and intercept, okay? Decide which side of the boundary line contains the solutions, okay? So that's going to be, is it a less than, so below, greater than, above? So which side of the boundary line contains the solutions? And then decide whether the boundary line is included or not, less than or equal to, greater than or equal to. So do they have the equal sign or not? That's our last kind of question we have to ask ourselves, okay? So if we're looking at this inequality, y is less than or equal to 2/3 x minus 3, we have our intercept and we have our slope. So we're going to go ahead and graph that. And when I say graph it, I don't mean actually draw the line in. I'm going to explain why you wouldn't draw the line in just yet. I know it says graph the line, but essentially what I'm saying is find its placement. So at -3 on my y, and I have a slope of 2/3. So I'm going to go up 2 and up 2 and over 1, 2, 3. Rise 2, run 3. Do it again. Rise 2, run 3. Okay, so I have my placement there. I could go backward too if I wanted to. I could run backward and down, so to follow the pattern, go backward and then down, just to get another point on there, backward and then down. I like to go all the way across my paper so I know where my line is. So that's where my line would be. The next question is, what does this symbol tell me about my inequality? It tells me that I want all the points less than my line. So I want all the points in this region down here below the line. So I will shade below the line. Okay. You'll shade in your graph below the line. And so less than means below, and the equal to means that the points on the line are included. And so how do I show that the points on the line are included? So remember at the top of the page I asked you to write dashed or solid. We show that those points are included with a solid line. So I'm going to go ahead now and make this line solid. And the reason I didn't want you to draw it in before is because sometimes that line has to be dashed. And if you go ahead and draw it in solid and then it's supposed to be dashed, you're going to have to erase the line and do it again. So there's my graph. The question asked you for all the values of y that would be less than or equal to this line. Those are all the solutions. Any point in that region is a solution. So in this case, actually, any point on the line or in the region below the line are solutions, okay? Any point on the line or in the region below the line. So I could choose any one of those ordered pairs to be a solution. Okay, let's try the second example. Again, we're going to go ahead and graph slope of 2, y-intercept of 1. So my y-intercept is 1, my slope is 2. That's the same thing as 2 over 1. So rise 2, run 1. So I'm going to rise 2, up 2, run 1. Rise 2, run 1. Rise 2, run 1. Again, I like to go backwards, so I'm going to go backward 1 and down 2. I like to do that just so I can go ahead and graph my line a little easier. You could always use a ruler and then you wouldn't have to worry about doing that. The symbol here, greater than, means that I'm going to be shading the region above the line because it's greater than. And since there's no equal sign, it does not include the points on the line, which means I'm going to make the line dashed so everyone knows the points on the line are not included. So dashed line, okay, and I'm going to shade the region above. So that means the solution this time is all of the region above the line. Anything in this region is a solution, not on the line, but everything above the line. Okay? Right? Let's move on to the next page. I'm going to go ahead and clear the page and then scroll. Okay, so let's move on to the next page. Absolute value inequality. So now we're going to be doing an absolute value. Let's go ahead and see if we can do this. So think back to when we were doing absolute value just the other day. The absolute value inequality is an absolute value function bounded by a line. Vertex. Okay, so the vertex is HK. That means when you think about the equation, remember H is inside. That is your left or right movement. Remember that? And remember it's backwards. Right is negative, left is positive. Tricky. Okay? And the K value on the outside tells you up for positive and down is negative. Okay? So just that's what the HK is for. So that is your vertex. So to graph a two-variable absolute value inequality, first we're going to find the vertex, and then we're going to choose values on the left and the right, and we're going to plug and chug. So the first thing I want you to do is change this. I want it to say the absolute value of x plus 3. Those other values, I don't know where I got that. I must have forgot to copy and paste when I was creating the notes. So we're going to go ahead and graph this function. And so what happened to my parent function, y equals the absolute value of x, if now it says y equals the absolute value of plus 3, x plus 3. So it happened inside the parentheses. It's a positive. That means I need to take my absolute value function and move it left 3. So first thing I'm going to do is go over here, Remember, my parent function would be here at 0, and we'd be going up 1 and over 1. I'm going to go backward 3, left 3, and then I'm going to go, oops, don't forget, we're not going to put our line on here yet. We're just going to go ahead and pencil in where it should go, up 1 and over 1. So I have the direction, right? But I haven't decided if it's dashed or solid yet. This is where I will put my function, okay? Now I need to decide based on this symbol. Less than or equal to means below. So I'm going to shade everything below the function, and equals means that it's going to be a solid line. So it is okay to go ahead and draw this in as a solid line. So that means everything on the line, and it was less than, so everything below in this region. Right? I will shade in this entire region down here. Okay? Let's try the next one. Okay, last one. So again, I want you to change this function. We're going to make it say y is greater than the negative absolute value of x plus 6 plus 2. So plus 6 tells me to go left 6. This plus 2 on the outside tells me to go up 2. And this negative tells me that it's going to open down. Right? It opens down. We've reflected it. The symbol tells me greater than. So I'm going to shade above. Whoops. I'll spell above today. We're going to shade above. And it's not an equal sign, so dashed line. So I have all the information I need. That's a great strategy to use, is to start off like this and then just mark down all the information that you know based on your equation, then go to your graph. So remember, we always start at 0, 0. I'm going to go left 6 and up 2. So 1, 2, 3, 4, 5, 6, up 2. There's my new vertex. This time it's going to open downward, right? And I know it's a dashed line. So my function opens downward and is dashed. And I'm going to keep right on going until I reach the edge of my page. I am shading above it. So I want everything in this region, not including the line, but everything above the line. Okay?